the graphs of y is equals to e power x and ln x. Okay, y equals to ln x. So today's date is the 5th of February, 2025. Now, so e power x and ln power x, by the way, how are they related? How are the two related? Let's see if you guys can answer that question. How are the two related, e power x and ln x? Or are they related at all to begin with? They're not related at all? Anyone? Anyone who'd like to answer that question? Do the two have... ln is log base of e. Okay, anyone else? There is a very strong relationship between the two. So here it is. Here it is. They are same thing. No, they're not the same. They're not the same. So let's say you have f of x is equals to e power x. Okay. And you're asked to find f inverse of x. Okay, let's say f of x equals to e power x, and you're asked to find f inverse of x. Notice what happens when I do that. So we do y is equals to e power x. All right. That's the first step before finding inverse. Now remember, we have to make, step by step, we have to make x the subject. So we take ln on both sides. Ln y is equals to ln e power x. Okay, so we've taken ln on both sides just so that we can get the power down since we are supposed to make x the subject. So ln y is equals to x ln e. As we know, ln e is equal to 1. So let's write this nicely. X is equals to ln y. So we have successfully made x the subject. Now the final step, that is f inverse of x. We replace x with f inverse, and we replace y with x. So that's equal to ln x. So f inverse of x equals to ln x. Now anyone can tell me what is the relationship between the two? It's pretty clear now. Reflection in line y equals to x. Basically, what I was looking, that comes after. You're right, that comes after. But what I was looking for was, yes, that they are inverse of one another. Okay, so f of x, e power x and ln x are basically inverse of one another. All right, so that's basically what the relationship is. So let's start with, let's first draw the graph of y equals to e power x. So when you plug in 0 in place of x, you're going to get e power 0, which is equal to 1. So that means the graph is going to look something like this. Okay, so this is what the graph of y equals to e power x will look like. So I'll color code it. This is basically the graph of y is equals to e power x. Then if I make the graph of ln x, by the way, can I plug in any value in ln x? Can I plug in 0? Can I plug in a negative value? Can I plug in a positive value? Or are there specific values that I can plug in ln? What's the answer to that? Positive, only positive values, not even 0. Okay, I can only plug in positive values in x. Yes, that's correct. Why? Because if you guys remember from logs, in order to keep a log function defined, especially a function like ln, its argument must be greater than 0. That's correct. So that means you can't just plug in any value that you like. You can only plug in values such as, well, you can only plug in positive values. And what is ln1 equal to? Pick up your calculator and find out. Ln1, you'll notice, is equal to 0. That means when x is equal to 1, y is equals to 0. So that is the x-intercept. So this is what the graph of ln x looks like. Okay, so this is the graph of ln x. And you can see, although they're not drawn to scale, but you can kind of see that they are a reflection of one another along the line y equals to x. And why is that? That's no coincidence. That is because they are inverse of one another. Okay, so this is the line y equals to x. This is the line y equals to x, and this is the graph of y is equals to ln x. Okay, so we're going to write down some important details about this graph, but first let's make some important, let's write down an important note. Ln x is the inverse Somebody's mic is open. Ln x is the inverse of e power x. Okay. Therefore, the graph of y is equals to ln x is a reflection of y is equals to e power x along the line y equals to x. Okay. So therefore, the graph of e power x is a reflection, or the graph of ln x is equals to a reflection of e power x along the line y equals to x. Now we're going to write down some important characteristics about both the graphs. Okay, let's start with y equals to e power x. First of all, this graph has a y-intercept. Okay, and what's that y-intercept? That y-intercept is 0, 1. Okay. Secondly, another important thing to observe is that e power x is greater than 0 for all values of x. Okay, so e power x is greater than 0 for all values of x. And technically, what is this? This becomes its range, that y is greater than 0. This is basically the range of this graph, correct? So if you look at all the y values, you will notice that they're greater than 0. Even though as x keeps on getting smaller and smaller, you'll notice that the graph will keep on getting closer and closer to the x-axis, but it's never going to touch, let alone cut the x-axis. So e power x is greater than 0 for all values of x. Now, another important key point. As x approaches positive infinity, okay, as x approaches positive infinity, what happens to y? Y also approaches positive infinity. As x approaches positive infinity, then y also approaches positive infinity. Basically, as x keeps on getting larger and larger, y also keeps getting larger and larger. Sir, is there any x-intercept for e? No, there is no x-intercept. Just like there's no y-intercept for ln x, there is no x-intercept for e power x. Sir, the line behind x equals to 0, isn't it less than 0 for values of x? No. This is the x-axis. This graph is will always be above the x-axis. Therefore, its y values will be greater than 0. Okay, we're talking about the y values right now. We're not talking about the x values. This is basically the y values. Here, y is greater than 0. Okay, now, another important key point is this. As x approaches negative infinity, okay, as x approaches negative infinity, meaning on this side, then what happens? Y approaches 0. Y is not equal to 0, y approaches 0. Then y, this arrow suggests that it is approaching. It's not equal to 0, it's approaching 0. Okay. And what about the asymptote? Where's the asymptote of e power x? Notice that it has does it have a horizontal asymptote or a vertical asymptote? So I'll make your life easy. Before you guys answer that question, I'll make your life easy. Let's draw the graph over here. It has a horizontal asymptote, that's correct. So y is equals to e to the power of x. There you go. In fact, let's just change this to e. So notice that it has a horizontal asymptote, okay? And that horizontal asymptote is y equals to 0. And what happens if I, let's say, add 1 to it? Then that asymptote changes to y equals to 1. If, let's say, I add, we're going to write down this general rule, don't worry about it. If I add 3 to it, then basically the constant that you have is the asymptote, okay? The constant that you have is the asymptote. The constant that's being added is the asymptote. So what if, for example, I subtract 3, then what happens? Y equals to minus 3 is the asymptote, okay? So the constant that you have, like I said, we're going to make a general rule for it and we're going to write that down, but that is the asymptote. Okay, so where were we? Yeah. So it's asymptotic. Okay, that means That's where the asymptote is. So it's asymptotic towards the negative x-axis. Okay, and the equation of the asymptote is y equals to 0. Okay, the equation of the asymptote is y equals to 0, which is right here. Okay, any questions? Achha, by the way, what is the domain? What's the domain of e power x? Is there any value that you cannot plug in? All x values are real. You can plug in all real values. Okay, so in this, you can plug in all real values. Therefore, the domain is all real values. So I'm going to add a little note over here. I hope you guys haven't copied it yet. So x belongs to the set of all real values is the domain, and y is greater than 0 is the range. Okay. Now remember this statement that we wrote earlier. Okay, you're going to see the connection very soon. What was the statement? Here. Domain of f of x becomes the range of f inverse of x. I'll explain it again. And range of f of x becomes the domain of f inverse of x. So we want to find out where does the graph become horizontal. So you can see that this graph becomes horizontal, almost horizontal. Now, that doesn't mean that it becomes a straight line, but the graph becomes almost horizontal as it reaches the negative x-axis. And what is the actual equation of the asymptote? It's y equals to 0. Okay, so the graph is asymptotic towards the negative x-axis, and the actual equation of the asymptote is y equals to 0. Now let's talk about, so I'm going to color code it to make it easy for you guys. Let's talk about y equals to ln x. So notice that this graph does not have a y-intercept. Instead, it has an x-intercept. Okay, so this graph does not have a y-intercept like the other. Instead, it has an x-intercept. And what are the coordinates of the x-intercept? They are 1, 0. So this graph has an x-intercept, and the coordinates of the x-intercept are 1, 0. Why is that? That's because this is a point, 0, 1. Since the two graphs are reflection of one another along the line y equals to x. So when you reflect it along the line y equals to x, 1, 0 becomes 0, 1 becomes 1, 0. Okay. I hope, have you guys done transformation in math? I know those of you are taking math with me, we haven't done it, but in school, I hope you guys have done it. Okay, great. Now, what is the domain of ln x? Notice that the domain of ln x is basically greater than 0. Okay, so ln x exists for only positive values of x. So e power x existed for all values of x, but ln x only exists for positive values of x. Why? What do you mean why? Why to what? Why to the first key point? Or why to this? Why does it exist for only positive values of x? Second point, use your calculator. Use your calculator, try and evaluate ln of any negative value. You'll notice that you get, you're unable to do it. And why is that? If you're wondering why that is, so it's like this. It's like this. If the question is log 4 base 2, okay, let's say the question is log 4 base 2. So why do we try an error in these type of questions? I'm not sure what you mean by that. So if let's say you have log 4 base 2, that means the power 2 is the base, and we know that whatever comes over here, whatever comes after the equals to sign is the power. So that means if you want, what should be 2 raised to the power of so that it's equal to 4? The answer to that is positive 2. Okay, and the power on 2 has to be positive, meaning that you can't take a base, raise it to a negative power, and expect to get a positive result. That's not possible. That's the reason why the argument of every log function must be positive. Okay? So, because ln की base क्या होती है? देखो, ln की base होती है e. Okay, the base of ln is e, which is positive. Okay, so that means the argument must also always be positive for us to get a result. Should we learn? Yeah, definitely. You should learn. You have to learn all these properties. Okay. Why do you think I'm writing all these properties down? You definitely have to learn them. Although you can find a connection, you'll be able to find a connection. If you learn one, you can figure out the other yourself. But at some point, initially at least, you have to learn all the properties. Now, what is the domain of ln x? You can see that the domain is x is greater than 0. So let's write that down. The domain is x is greater than 0. What about the range? What do you think is the range of ln x? I'll zoom out so you guys can see what the connection is. What's the range of all real values? That's correct. So here we can say that y belongs to the set of all real values. That's the range. Can you see the connection? Notice that the domain of f of x is the range of f inverse of x. The range of f of x is the domain of f inverse of x. Okay? Now, here. What happens as x approaches positive infinity? Y also will approach positive infinity. So as x approaches positive infinity, then y also approaches positive infinity. Basically, all you have to do is swap places of x and y here, and you will get the details for ln x. Here also, I'll swap places of x and y, and we will get details for ln x. So notice what happens here. Here we say that as x approaches 0, then y approaches negative infinity. Okay, so you can see here as x is approaching 0, y approaches negative infinity. And where is it asymptotic? This is asymptotic towards negative y-axis. And what's the actual equation of the asymptote? Let's write that down also. The equation of the asymptote is x equals to 0. Okay, notice that the equation of the asymptote is x equals to 0. Now, I want you guys to have a look here. Y equals to ln. Where is ln? Here it is, ln x. What's the asymptote? The asymptote is x equals to 0. Okay, asymptote, as you guys know, is a line, could be vertical, could be horizontal, that a graph approaches but never touches, let alone intersects. So you can see that the asymptote is x equals to 0. Okay, now what if I do x minus 1? What's the asymptote now? Now the asymptote is x equals to 1. What if I do x minus 2? What's the asymptote now? The asymptote is x equals to 2. What if I do x minus 3? What's the asymptote now? It's x equals to 3. What if I do x plus 3? What's the asymptote now? It's x equals to minus 3. Do you see a connection? Do you see a connection? What's the connection? How do we find the equation of the asymptote? Let's change this back to minus 3. How do we find out the equation of the asymptote? Kya baat hai? Today you guys seem awfully quiet. Are you guys still in holiday mode? Are you guys off from school today? I guess that's why. Yes, so basically we take the argument and we set it equal to 0. Thank you. Find the value of x that makes it equal to 0. Yeah, so we take the argument, we set it equal to 0, and that's it. We get the equation of the asymptote. Okay, so how do you find out the asymptote for y equals to e power x? The way that you find out the asymptote, isko general rule bana lete hain. Let's say you have y is equals to e power x plus a, then the equation of the asymptote will be y equals to a. Okay. Here, let's say you have y is equals to ln x minus b, then the equation of the asymptote will be x equals to b. All right. So I hope it's clear now. This is the general rule that I was talking about. Now, with this in mind, let's solve a few questions. Okay. And a couple of rules that I would like you guys to, although I'm sure you guys know this already, but chalo likh lete hain isko, especially when it comes to e power x. So this is what the graph of e power x looks like. Okay, we all know what the graph of e power x looks like. Yeah, in fact, let's not add this to our notes. Let's just visually have a look at this. So we have y is equals to e to the power of x. Here it is. What if I multiply x by minus? What will happen then? What if I do y equals to e to the power of minus x? Question for you guys. What if I do y is equals to e raised to the power of minus x? How will the graph of e power minus x be related to y equals to e power x? Remember what happens when you change the sign of the x coordinates? Transformation, O-level IGCSE Math transformation. Let's see if you guys remember. What happens when you change the sign of x? Or what happens when you multiply x by minus? You multiply all the x coordinates by minus. What happens then? It flips mirrored. Okay, mirrored, that's correct. Mirrored along which line? If x is multiplied by minus, then it becomes a reflection along the y-axis. That's correct. So notice that this is the actual graph, and this is the graph of y e power minus x. It is a reflection along the line, along the y-axis. What if I multiply the entire equation by minus? Tab kya hoga? What if I multiply the entire equation by minus? Meaning, if I multiply all the y coordinates by minus, then what happens? Question for you guys. It's a reflection along the x-axis. Let's have a look here. Yep, that's correct. It is a reflection along the x-axis. Okay, so remember these rules that if the power is multiplied by minus, it's going to be reflection along the y-axis. If the entire function is being multiplied by minus, that means it's going to be a reflection along the x-axis. Okay, so I can make a general rule for it if you want. If let's say you have y is equals to e raised to the power minus x, then this will be a reflection of y equals to e power x along the y-axis. Because the value is so large that your calculator cannot compute it. That's why you're getting a math error. No other reason. Try and figure out 2 raised to the power 600. I'm sure you get a math error for that as well. Karke dekho, tell me what you get. 2 raised to the power 600. You'll once again get a math error. Yeah. It's not because it's not, you can't calculate it. It's not one of those situations that it's 1 upon 0. 2 upon 600 is something that can be determined. Okay, 2 upon 600, 2 to the power 600 is something that can be determined, but your calculator just doesn't have the capacity for it. That's the reason. So here you go. This is y equals to e power minus x is a reflection of y equals to e power x along the y-axis. And here, y is equals to minus e power x is a reflection of y is equals to e power x along the x-axis. So there you go. Okay, now that this concept is now done, what we're going to do is we're going to solve some past paper questions. So I've taken out some questions already. Let's solve them one by one. here is a question. The function p is defined by p of x equals to 3e power x plus 2. Okay. State the range of p. See if you guys can answer this question. Try and visualize the graph of e power x multiplied by 3. Not going to make a huge difference. But what if you do plus 2? What is the asymptote going to be? The asymptote is going to be y equals to 2. So that means the graph that we're talking about looks something like this. So here's 2, and this is what the graph looks like. The asymptote will be at y equals to 2. So what do you think will be the range of this graph? What do you think will be the range of this graph? I've almost answered the question for you guys. All you have to do is give me the final answer. So if you guys can do that, that would be great. What will be the range of this graph? Greater than 2. That's correct. So we're going to say p of x is greater than 2. Not even greater than equal to, just greater than 2. Okay, so that's the answer to the first part. Now, on the axes below, sketch and label the graph of y is equals to p power x and p of x and y equals to p inverse of x. State the coordinates of any points of intersection with the coordinate axes. Now, earlier, I think it was in the last class, it was yesterday's class, somebody asked, how do we know whether the graph of e power x and its inverse, actually not e power x, but somebody just generally asked a question, how do we know whether the graph of f of x or f inverse of x will intersect or not? So first of all, a standard rule, any exponential graph and its inverse will not intersect. Okay, any exponential graph and its inverse will not intersect. Okay, as far as other graphs are concerned, those graphs, whether they intersect or not, we'll have to check there and then. There is a way to check, which we're going to learn. We might come across a question like that today only, but the way that we check is, so I'll add a note. Okay, where should I add a note? I'll add a note over here. So the note is that any exponential graph that is y is equals to e power x and its inverse. Okay, what does the inverse look like? This is what the inverse looks like. Y is equals to ln x will not intersect. Okay, they will not intersect. That's it. So here is the graph of p of x, which is equal to 3 e power x plus 2. Now remember, we know from prior knowledge that this graph will have a y-intercept, but will not have an x-intercept. So how do we find out the y-intercept? You plug in x equals to 0. So if you plug in x equals to 0, or let's say p of 0, doesn't matter what you call it. So p of 0 becomes 3 e power 0 plus 2. E power 0 is 1. 1 into 3 is 3. 3 plus 2 is equals to 5. So that means the y-intercept is 5. And remember, the asymptote is 2. So that means this is what the graph looks like. Remember, it's a sketch, so don't waste your time trying to get everything exactly right. You just have to make sure that you get the coordinate axes right. Now, the graph of inverse has to look like a reflection of this graph. Okay, so that's important. The inverse graph should look like a reflection along this line. So that means if that graph had an asymptote at y equals to 2, the inverse graph will have an asymptote at x equals to 2. And if f of x had a y-intercept at 5, this graph will have a x-intercept at 5 as well. So that means this is what the graph will look like. So let's complete the graph. And here we go. That's it. Job done. Do the two look like inverse of one another? Yes, they do. And that's it. Job done. I'll repeat the inverse part. So inverse part में हम x को y बना रहे हैं, y को x बना रहे हैं, ठीक है? अब ये एक asymptote है. What's the equation of the asymptote of this graph? Y is equals to 2. Okay, so the asymptote is y equals to 2. For the inverse graph, the equation of the asymptote will be equal to 2, but not y. It will be x equal to 2. So the equation of the asymptote for the inverse graph will be x equals to 2. Okay, and remember the inverse graph is going to look like this. You have to memorize the shape of the graph. Like for example, here, how did I know to make a graph like this and not a graph of sine or cos? Because we have to memorize the shape of every single graph. So this is what an exponential graph looks like. That's why I've drawn a graph like this. And we know from prior knowledge that if we take inverse of an exponential graph, it's going to be a graph of ln, and this is what it looks like. So it's going to have a vertical asymptote at x equals to 2. You can see that's the case. The y-intercept of f of x is 0, 5, which means this graph, the inverse graph, will have a y-intercept or will have an x-intercept at 5, 0. That's it. Okay, makes sense? So great. Let's do another question. We have 3, 4 questions, inshallah, that we're going to solve in today's class, which will help you understand the concept. What is the job of asymptote? Good question. The job of asymptote is to give us limits. Like for example, here, the job of this horizontal asymptote is to give us the limit of the y value. Okay. Here, the job of the asymptote is to give us the limit of the x value. So we know that here, the value that can go in the inverse function have to be greater than 2. Here, we know that the range of this function has to be greater than 2. How do we determine? So the reason why the way that we determine is that if it is an exponential graph, it's going to have a horizontal asymptote. Why? Because we know from prior knowledge that exponential graphs are asymptotic towards the x-axis. Could be negative, could be positive. So an exponential graph is either going to be like this, or it's going to be like this. Okay, or it could also be like this, or it could also be like this. So it's going to be asymptotic towards the x-axis. So that means it's always going to have a horizontal asymptote. The graphs of ln are always like this. So that means it's going to be asymptotic towards the y-axis, could be positive, could be negative, depending on the sign of the graph. That's how we know. Are these limits? Yeah, these are the limits that we use in calculus. Yes. Limits का concept भी यहीं से derive होगा. We don't have to do that. We don't have that in our syllabus, but later on, when you guys do calculus, as in calculus 1, 2, 3, a proper course on calculus, you'll understand the concept of limits through asymptotes as well. Anyway, here's a question. Let's solve this. It says the function f is given by f of x equals to 5 minus 3 e raised to the power half x. And x belongs to the set of all real values, and we have to state the range of f. Now, please don't jump to conclusions. Don't jump to conclusions and just give the range. Let's figure it out and let's do it together. So this is f of x equals to 5 minus 3 e raised to the power half x. First thing that I would suggest is that you write this nicely. Okay, write it like this. Minus 3 e raised to the power half x plus 5. Okay, just change the order. I haven't changed the signs or anything. I've just changed the order slightly. Now, how about you guys give this a shot? What do you think the range here is going to be? Is it going to be greater than 5 or lesser than 5? What do you think? Greater than 5. Okay. Are you sure about that? Why do you say lesser? Why do you say lesser? Yes, because there's a minus sign. Now they go. Earlier questions like these used to come, well, it didn't matter earlier whether a question like this came in paper 1 or paper 2. Now I'm expecting questions like these to maybe, at least the first part, this part, I can swing either way, but at least the first part is something that can come in paper 1. So you should know how to do this without a calculator. So it's very easy. we know the graph of y equals to e power x. What does that look like? This is what it looks like. Okay. This is not the graph of e power x. This is a graph of minus 3 e power x. Yes, I know it's half, but this half is not going to change the shape. Okay, yes, maybe it'll be a bit wider, narrower, but it's still going to be something like this. But because of this minus 3, that means now the graph will look like this. Okay, so this is the graph of y is equals to minus e power x. Now, even if it's minus 3, it's still going to look the same. But what if I add 5 to it? If I add 5 to it, then what happens? Then this graph moves 5 units up. Okay, now the asymptote will be at 5. That means the graph is going to be something like this. The asymptote will be at 5. Okay, so what is the range of this graph? The range of this graph will be y is less than 5. Not greater than 5. It's going to be y is less than 5. Okay, I hope it's clear to everyone. I'll go over it from the beginning. So the graph of e power x looks like this. But since this is the graph of e power x, which has a negative coefficient, that means it's going to be reflected along the x-axis. Then the asymptote, which is at y equals to 0, if you add 5 to it, the graph shifts 5 units up. That means this is what the graph now looks like. Whatever the y-intercept is, we're not concerned with that, but the asymptote will be y equals to 5. Why? Because we can always find out the y-intercept by plugging in x equals to 0, just so you know it's going to be equal to 2. Okay? So as you can see, the shape of the graph is such that the greatest value it reaches is 5, and all the other values are less than 5, so that means it's going to be y is less than 5. So moral of the story is don't just look at the constant and write down the range. Look at the sign on E, look at the coefficient of E, see what the shape of the graph is, and then determine the range. If you remember, I said it earlier also that in order to find out the range, although I said it for many to one functions, but this applies here also. In order to find out the range, your safest bet is to actually make a sketch and then do it. Okay, in order to find out the range, remember your safest bet is to actually make a rough sketch and then do it. So I hope it's clear to everyone. Now let's do the following part. The following part says solve the equation f of x equals to 0, giving your answer correct to 2 decimal places. Okay, so actually I'm going to skip this. And the interesting part is, okay, here's the interesting bit I just realized. Notice that you have to sketch the graph, correct? You have to sketch the graph. So what you can do is you can first sketch it and then answer part 1. So you can do that also. You can solve this first, and then give the range. Okay, it's not like the examiner is going to find out. And even if the examiner finds out, you're not doing anything wrong. So let's do part 2 and part 3. In part 2, we have to do f of x equals to 0. That means 5 minus 3 e power half x को equals to 0 करना है हमने. So let's solve this. 5 is equals to 3 e power half x. So that means 3 e power half x is equals to 5. Let's write this nicely. E power half x is equals to 5 upon 3. Let's use ln to solve. Ln e power half x is equals to ln 5 upon 3. Let's find out the value of x. So ln of 5 divided by 3, we will be given, yes, you will be given a grade of obviously into 2. So x is equals to 1.02. What did the question say? Correct to 2 decimal places, so 1.02. There you go. Now part 3. Part 3 says sketch the graph of y is equals to f of x. So let's make a rough sketch. So we saw that the y-intercept of this graph is, let's see what the y-intercept is going to be. Just plug in x equals to 0. So it's going to be 5 minus 3 e power 0. E power 0 is 1. 3 into 1 is 3. 5 minus 3 is 2. So the y-intercept of this graph is 2. And the asymptote is 5. And it also has an x-intercept, which is 1.02. So that means if here's 1, somewhere over here, the graph will cut the x-axis. There you go. Now, I should mention that this is actually not the correct shape. it should get horizontal as it approaches 5. There you go. So if it was 3e power minus half, minus 3e power minus half. Okay. If it was minus 3, yes, it would still be less than 5 because in that case, it would be reflected along the x-axis. Achha, wait a minute. Your question is, if it was minus 3 e raised to the power minus half. Okay, so this is minus 3 e raised to the power half. Yes, in that case, it would be reflected along the y-axis, so it would still be less than 5. Yes, that's correct. Okay, so I hope it's clear. Now let's see if we have time for another question. So this graph has both. Yes, this graph has both. The reason why it has both is because it has been shifted, it has been moved. That's why it has both x and y intercepts. And notice the question is usually going to be very nice in the sense that it will already make you find out the x-intercept. And then it will ask you to sketch. What's the difference between math and add math vectors? Okay. Add math vectors are math vectors on some very nasty steroids. Yeah, let's put it that way. And then there's more. Then there are velocity vectors as well. We didn't do part 4? Okay, yeah. So you guys can do part 4. In fact, let's do it. Let's do part 4. I'd like you guys to do part 4 and give me the answer. Then so if our math vectors is weak, then our add math vectors, yeah, I'm afraid that's the case. But here's the thing. Here's the thing. You know, it's not always linear. It's not as if that you need to work on math vectors or you need to bring your math vectors up to a certain mark in order to be able to do well in add maths. Maybe this could be the case that if you understand add math vectors, you might start finding math vectors a lot easier. That's also possible. 2 ln x minus 5 upon 3. That is... Achha, 5 minus x upon minus 3. Yeah, that's correct. Wait, I was wondering there's something wrong with the sign. So the inverse, this is what the inverse will look like. It's going to be... Okay, I'll do that. 2 ln 5 minus x upon minus 3. That's correct. Or you can also write it as x. No, actually, you can write it as 5 minus x upon 3 or x minus 5 upon minus 3. So x minus 5 upon minus 3 bhi chalega, or 5 minus x upon 3 will also work. Okay, so last question, quickly solve this. And let me answer your question, Shumaim. Can you please tell me how 2x equals to ln 2 is equal to x ln under root 2? Oh, okay. I feel like vectors is exaggerated, low-key, and I think so too. I feel the same about vectors, and I feel the same about number sequences as well. I feel like ye dono topics, for some reason, are their difficulty level is exaggerated. So Shemaim, you've asked that why is 2x equals to ln 2 equal to x? In this case, is x is equal to ln under root 2. So the answer is very simple. If you make x the subject over here, it becomes ln 2 upon 2, or you can write this as 1 upon 2 ln 2. Okay, ab ye remember the power rule? So I can rewrite this as 2 power half, and 2 power half is basically root 2. ठीक है, और ये चीज़ आप उल्टा भी कर सकते हो. You can rewrite this as 2 power half, then half gets multiplied. So x is equals to half ln 2. Yes, I hope that answers your question. I don't exactly remember what rule number this is, but I hope it answers your question. So the thing is, I don't know where did the 1 upon 2 came from. Tell me the exact question. Share with me the exact question that you're talking about. Okay, I'll give you guys the answer to this. It's 0.662. Okay, so what's the answer? It's 0.662. Then part 2, obtain an expression for f inverse. I'll just write down the answer. The answer would be ln 4x minus 1. So it's f inverse of x equals to ln 4x minus 1. State the domain and range of f inverse. Now let's start with the range. Range is easy. So the range would be that f inverse of x is greater than or equal to 0. Why? Because that's the domain. That's the domain of f of x. As far as the domain is concerned, so let's determine the range of e power x plus 1 upon 4 by writing it separately. So the range of this function would be greater than 4. F of x is greater than 1 upon 4, sorry. So that means the domain, or domain आप यहाँ से भी निकाल सकते हैं. Just take the argument and set it greater than 0. So you'll have 4x, which is greater than 1, which means x is greater than 1 upon 4. That's the domain right here.